Ladies and gentlemen, it's a wonderful Monday here at East Jackson. It is September the what? 24th. And we have to determine whether things are exponential, linear, or not. Now, yeah, and then say why, right? Why? Okay. Is number one linear? Yes or no? Exponential? Okay. How do you know it's linear? Ah, so it's linear, has a constant. How do you know what's the slope? Anybody calculate the slope on that? That would be negative 1/2 over negative 3/2. So, for grins and giggles, let's do this. Well, that's like really multiplying it by negative 2/3, which would be boom, boom, boom. That'd be a slope of 1/3. How we doing? Right? Because wouldn't that be, that'd be negative 2? I mean, positive 2 over 6, right? Because this is keep change what? Flip, good. All right, any questions off that? Are y'all solid with that? Ladies and gentlemen. Okay. Huh? I do. What you gonna give me? Well, give me the answer to number 2. Tennis tournament. Well, boom, 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 boom. Well, that goes down by 32. That's by 16. So that joker is not linear, is it? No, can't be linear. So what would it be? Exponential, right? It's exponential. The R is 1/2, right? That's what we looked at. Listen. Shh. That's what we looked at when we were looking at sequences, right? Geometric. When we look at exponentials, which are a times b raised to the x, the b is the base. That's what's being raised to a power, right? So you need to make sure that we're talking the same vocabulary. B is base, right? You with me? Okay. Now, so the base, or the R, would be 1/2, right? Okay. So, why? Because it's going down by constant what? Ratio? 1/2. So, what's another reason? I mean, could we come up with another reason? Yes or no? No? Yeah, we could. What is it then? Okay. Well, if you go sit there and say no or yeah, and then I say, well, what is it? Well, I don't know. Then don't say that. That's kind of being All right, ladies and gentlemen, what is that equation of? Y equals 4x. What is that equation of? It's a linear equation. It's really y equals mx plus b, right? Now, what's the y-intercept on this one? 0. Thank you. So don't be tricked with that, okay? Why? Well, how do you know by looking at it whether an equation's linear? Anybody know? We're only looking at equations. We don't look at equations. No. What should the powers of y and x both be at? 1. Thank you. Good job. When you have both the powers of y and x at being 1, then the equation is linear. Now, the function is decreasing at a constant rate. Rate is not the same as what? You understand? So, okay, hold up. How many of y'all put linear? I'm just curious. How many of y'all put exponential? It's not ratio, it's constant rate. It's linear. That rate is a rate of change. Thank you. Right? If it is decreasing at the same constant rate, ladies and gentlemen, then it's going to form a straight line. Yeah? Y'all good with that? Y'all sure? Okay. You can't see the board looking back at me. You got to go that way. I've taught middle school for 5 years. I've perfected it after day one. Now, is this linear? No. Is it exponential? Okay, first off, how does an exponential look like? Or what does an exponential look like? Oh, I can't do that. That's bad. It looks like this. Like that. Or, which way? Other way. Right? Like that, right? It ain't going to be even, dude. I'm just giving you a... That's right. That's neither one of those. Y'all know what that right there really looks like? Anybody know what that really is?
What's it called? No, it's
All right. All right. A person's height as a function of a person's age. Person's height as a function of a person's age. From 0 to 100. All right, so y'all look right here. That joker gonna be like that, isn't it? Like that, right? But it won't always be a straight line, right? Well, honey, they could be shrinking. You could grow.
There's no such thing as a shrinking machine, Josh.
Don't you grow based off your cells dividing, and then what happens to those cells? Like, how do you shrink? Your cells are constantly dying.
It's called gravity.
So, is this linear, exponential, or neither? All right, good. Hey, shh. Look right here. Do you see how I drew this? When you see that as a function of, it's always output, then OTI, right? OTI. So, the input, which is the X, is a person's age from 0 to 100. If you do a mock graph of that, you can clearly see definitively where you're going to be at, right? Yeah. I mean, even looking in here, we say stand up. Not everybody's at the same height. Right? So, all right. What about this right here? Linear, exponential, or neither? Hey, did I give y'all this one? Is this on the back? It's on the back. Good. Linear, exponential, or neither? It is a linear. What form is it in? Well, let me back up. It's really not in standard form. But
If you subtract 7,
if I moved, hold up, if I moved the 7 to the other side and divide by 4, I could put it in slope intercept. If I took the 4y and moved it to the other side, then it would be in standard, right? X, y on the same side. But y is to a power of 1 and x is to a power of 1. There you go. Now, I always look at these. These changing in x's, boy, baby's moving by 2, aren't they? Okay, now let's look down here. 23 to 5, that's minus 18. Minus 18, minus 18, minus 8. So it has a constant rate of what? Good job. It's linear. That's why. Definitively, you can say why. Does that make sense? Some of y'all were like, I don't know how to say it. I can get it, but I don't know. You got it now? Good. You got to know that you know, you know. You know? All right. Ladies, are y'all learning? Y'all sitting there talking about nails?
No, I'm learning.
Y'all, I'm afraid y'all learning about manicures and pedicures and stuff and not math. That scared me. Now, y'all ready? Here we go. Let's look at this one. How are these moving by? 8. Oh, my. That's 8. That's what? Negative 4. That's what? Negative 3. That's what? Negative 14. That's what? Positive 5. Look at these. That's 7. That's 4. That's 2. Yeah, it is. It's a negative 4. Thank you. That's a negative 7. That's a positive 3. Listen, are any of these linear or exponential? Yeah, because 13 divided by 6, 9 divided by 13, 11 divided by, there's no common ratio there neither as well. How we doing? All right, the number of cell phone users in Centerville as a function of the what? If the number of users is increasing by 75% each year, first off, who's input, who's output? As a function of. So that's an output. This is a what? So the years is down here. This is number of what? Users, right? Yeah? Okay, it's increasing by how much? 75%. Now, is that a constant rate? No. Because I take 75% of something. That ain't the same as 75% of something that's less or much more, right? I take 75% of 100, that's 75. But if I take 75% of a dollar, that's 75 cents, 0.75, right? Big difference, depending upon what you're talking about, right? All right, so this would be a base of 1.7 what? Why would it be a base of 1.75? Raise your hand if you know why. 1, this is exponential. 2, why would it have a base? Go. You got it. You nailed it. You have to include the 100% of what you have plus another 75, right? So if you take percents back into decimals, 100 is 1, 75 is 0.75, so add them together, folks, that's 1.75. All day long. Right? Okay. What about this one? Linear, exponential, neither. Anybody want to know why?
The constant rate changes.
There's no constant rate of change, son. That's not a it's a common ratio. Ratio. Not radio. Ratio. It's a common ratio, right? Not a radio. Now, listen here. Here's something to understand. Why would you expect this exponential to cross 1 on the y-axis when your x is 0? Raise your hand if you know why. Why would you expect that particular exponential to cross at 1 on the y-axis when your x is 0? Raise your hand if you know why. Nobody knows? Nope. I said it twice. If you checked out twice, that's on you. Yes. Nope. All right, Michaela, go. It's not it. Go. No. What you got? Nah. Go. Nah. What's the zero power rule say? No, sir. You jumped the gun. You put the cart in front of the horse. That horse is confused right now. Say it again, but slow down. Go.
Zero power.
Anything raised to the power of 0 is what? 1. Yeah, you just saying stuff. We need some substance behind that. Okay? Okay, 12. You don't have 12? Oh my God, stop. Stop the presses.
No, but you're not supposed to.
All right, if you'd like to know why your kid is doing so bad in this class, just listen. Yeah. Now they close their mouths. Okay, so the time it takes you to get to work as a function of the speed in which you drive. Now, what you have to understand is this as a function, it's output, then what? So the input is what? Speed. What's output? Time. Is that linear, exponential, or neither? Well, the slower the speed, the greater the what? Wouldn't it be like that? Huh? Wait, it can't be the other way. This is 0 here. So, if slower my speed, the more time, right? And as my speed increases, guess what happens? My time does what? Huh? Listen, if you have a problem hearing me, you need to go have your ears checked. Think about what? Stop. The time it takes you to get to work as a function of the speed at which you drive. It doesn't say speeds. It says speed singular. Do you understand? Oh, light bulb comes on. And we ain't going on looks. We're going on what we know. I know. No, it is not supposed to go uphill. Son, You need to look right here and understand that if I have the greatest time with the lowest speed, crawl. I tell you what, crawl to the bathroom and let's clock it. Stop. Okay, then I want you to walk. Then I want you to run. Do you understand? The faster you move, the slower the time. All right. Okay, good. You got to think about it. They reversed it on you. Y equals 7x squared. Is it linear, exponential, or neither? That's quadratic. It's neither. See, hey, stop. Stop. One, it's not linear because x is raised to a power of what? 2. Y is to a power of 1. Now, 2, for it to be an exponential, the variable must be in the exponent. Is that variable in the exponent? Ladies and gentlemen, you need to complete this exercise and your homework. Bring it back to me tomorrow.